Good afternoon, everybody. Thanks for joining us today. My name is Greg Wadley. I'm with CTC & Associates. I'm the Clear Roads Administrator. We're here today for a webinar, a final closeout webinar for Project 1404, Plug and Play Phase 2. The principal investigator for this project is Scott Peterson with SRF Consulting. This closeout webinar is a requirement of all projects as we get to the end of the project duration. Around the time of the final report, we go ahead and conduct one of these webinars. So this is meeting the requirements for that deliverable. With larger groups like this, we put everybody's lines on mute, which I've already done. So if you have any questions or comments, please put those in the chat box. And I'll be putting a note in there as a reminder for those who are joining after this to know to do that as well. So with that, I'm going to turn it over to Scott Peterson with SRF for his presentation. Go ahead, Scott.
Okay, thank you, Greg. And I'll just keep an eye on the chat pod in case anybody does have any communication about the presentation as we're going on here. So I'd like to welcome everyone to the presentation today of Plug and Play Phase 2. You'll note here it says January 2017. Right now it's November 2016, but the expectation is that the project will be completed in January 2017. So that's why we put that date on. The overview of what we're going to cover today is first talking about the description of the need, why this project came to be, the literature review we did, then talk about two surveys. First, the agency survey, where we surveyed about, we sent it out to about 50 different representatives and got back about 30 responses. Then also the industry survey results, and then we have been discussing what do we do with those findings and what kind of conclusions and recommendations can we make. So first, the description of the need. The basic need is that agencies need a standardized way to communicate between their plows and the central office. And that's the simple need, but there are some other extenuating circumstances such as interagency communication. And one of the limitations is that the current software, so for example, I'm in Minnesota, and Minnesota DOT has a system for doing this type of work, and Greg Wadley is in Wisconsin, and Wisconsin DOT has different systems set up, or a different organizational infrastructure set up. And so just thinking of about it in a simple way is how do these agencies communicate with each other and communicate their data? First step is to get it from the plows to a central location, and then another future step is hopefully to be able to share information among agencies. You notice here that there's also the item about equipment interoperability. So within a given agency, they might have different, say, legacy systems, or might have in different regions have different types of systems, and it would be useful to have these systems be able to communicate with each other. So that's the whole concept for Plug and Play. The Phase 2 part is that in Phase 1 there was a protocol developed to be able to communicate between AVL systems and spreader controllers. And then the concept of Phase 2 is how do we go outside of the cab? How do we get the information from those mobile vehicles to the central office? And is there a standardized way that we could certify as Plug and Play? And we'll talk about more about the findings as the presentation goes on. Now we'll shift over to the literature review. Just wanted to do some basic information about what I was just talking about. Now, not only do we want to be able to communicate among agencies, there's also different communications links that these plows might need. And it all just depends on many factors that any given state might encounter. So by far, it appears that the most common method is the cellular method, and some states are also using radio. So it'd be radio from plows to a radio tower, and then to the central office. And then still others don't necessarily communicate while the vehicle is out in the field, it might communicate via Wi-Fi when it comes back to the garage, or potentially by Wi-Fi as it would pass certain waypoints that are out in the field as that truck is driving around. That's less common. The cellular is the most common, and the radio link is also used sometimes, and then the Wi-Fi is maybe more used for a larger payload data dump if that needs to happen. Just some overview on what DOTs use AVL and GPS systems for. A lot of it comes down to remotely being able to efficiently route vehicles and control the snow efficiently. It's also important to be able to track vehicles as they're in remote areas. Sometimes you might just need to know where those plows are, and that's a way to bring them back or give them more information without needing them to come back to the garage. So it's a pretty basic need, and it's one that we found that many agencies really depend on. Another one is recording the vehicle usage history. So, and I would say that even extends beyond just when the vehicle was used, but also an end of plow or an end of route information dump from the vehicle about where it was spreading material or where it was plowing. So not only can that happen in real time, but also back in the garage too. Real-time road conditions. We'll see that was a big factor for agencies. Measuring bed weight and material usage, and capturing roadway images. Now here's a little more background about what the protocol, so we've been talking about the plug-and-play protocol, what a protocol actually looks like. So here's just one example of a protocol. So this is for Dickie John control point equipment. And you can see it has, in these blue numbers indicate each of these fields, and then there's a description of the protocol. So one of the goals of this project was to be able to assess whether the protocols that are out there are meeting the needs of the agencies, and how the protocols could be changed in the future to also meet those needs even better. This communication schematic shows a different way of looking at it, rather than just, remember we looked at that communication schematic that showed the graphic plow and the building. Now let's look a little more granularly. The building is represented at the top of this graphic as a office head-end system, and then all of these other devices are on the vehicle. So the link between the office and head-end system most commonly goes to a single communication point, although that could be different communication methods for those agencies that do require alternative communication methods or multiple communication methods. Then below that is a data management controller. So the idea here is that all of the data gets aggregated, or especially all the plug-and-play, maybe you could call certified data, gets managed back at the data management controller, and then that's communicating with the communication system. So in some senses, that could be an AVL equipment that would be aggregating, or it could be a spreader controller that is integrated into the AVL that's serving as that data management controller. Now notice we also have a box that is off to the right that's called non-plug-and-play devices. And so we wanted to acknowledge that there are going to be new products that come out into the market that maybe don't fit in with what has been certified to be plug-and-play or certified to be interoperable, but agencies may still want to use that. And in those cases, they might just directly interface with the communications, whether that's that single communications box or an alternative communications box. But we wanted also what's written there in gray as logical references to the data. So rather than sending the payload of a video stream, for example, or sending the payload of an image through the data management controller, it might be more likely to send a logical reference. So send a link, so the actual payload goes through just directly communicated, but a link still gets passed through the data management controller because that's just a string of text. That's another way of looking at these various devices and how they would be aggregated up and into the communication system and then sent off to the head end. We have AVL positioning, spreader controller mentioned, and then other plug-and-play devices. And as we work through this presentation, you'll see just how many other plug-and-play devices potentially there may be out there. And I guess that now is probably a good time to talk about that. So we'll get into the agency survey results. Now, these are sorted by the percent that we're using it. And so basically, we asked for all of these parameters. And there's a few slides of these, but they're sorted by data type. These are the vehicle data types. So these were attributes that we asked about that we thought pertain specifically to the vehicle. And you can see that these parameters that we've been talking about, vehicle location, speed, are the most important, or are the most used. 82% are using, and my guess is the ones that aren't using it would really like to be using it. And then we also asked each of the agencies to give an importance score. So we asked them to score it very important or not important, and then it had a 5-scale range. And then we took the average of those and multiplied by 100, or I guess multiplied by 20. 5 points times 20 would be a perfect score of 100. So you can see that 94 is an extremely high importance score for the location. Speed was also found to be very important, as well as idle time. The ambient air temperature coming off the truck was important, and then the electronic control module, vehicle diagnostic codes were also important. And you can see and then I guess the run times since start, that would hit all the ones that are above about 40 or so. So this list is sorted by the percent that are actually using it. And we took the percent using and the importance score, basically subtracted the percent using from the importance score and came up with a gap analysis. And what this reflects is a really positive number, reflects that it's maybe underutilized. More people think it's important than are actually using it. And the other ones that really stand out there are the ambient air temperature and then the electronic control module codes. So you can see we also asked about some of these lesser important ones, lateral acceleration, throttle position. You can tell that there are some core features that agencies really want for these devices. The next slide is about spreader data. As you can see, there's definitely a hunger for that kind of data, but also quite a few are using it. So the ones that are, the gap analysis came out the highest were actually ones like gate setting and the spinner dial settings and their pre-wet tank level. So my expectation is those are just opportunities for the industry to move towards, but they seem to already be meeting the needs when it comes to spreader data types. So a few data types on this slide. Environmental data types, those were found to be very important across the board. The pavement temperature and air temperature, so this would be from an external air temperature versus off the vehicle, both found to be very well used, but the other types were also found to be important but lesser used. So like humidity and precipitation sensor, surface grip, and sun sensor. And I know there's a future project coming out to assess some different mobile sensors that would provide some of this kind of data. The operator interface and controller data types, again, found to be very important, basically across the board, but the one that is used the most is the plow status up and down, and these other data types are not being used as much, less than half. That would be a chance, like road condition or weather condition, that would be a chance for the operator to manually input what they're finding on the road. And then the final one for the agency survey is image, video, and traffic data types, and those again were found to be relatively important, in the 50s, but not many people are using them. And I guess I see a news article every now and then about a new agency that has adopted a dash cam or other, basically trying to bring images back rather than just data. The image has a lot of importance too. That was the agency survey. We also did a survey of the industry. And this industry survey was actually fairly difficult to get responses. And basically, we kind of came to the conclusion that there's not that much in it for the freight industry to help us with this survey. We tried to make the best case for, just think of this image right here of, we even have a driver outside of his vehicle. This is the type of situation where I would hope that the freight industry would try to get more involved with helping the agencies out, but there just wasn't much of a response. So we got some responses from national carriers and regional carriers, and then we also had a good discussion with one of the biggest freight industry suppliers of vendor equipment. So that would be the type of equipment that those big freight companies like FedEx and J.B. Hunt, those are the systems that they use on board their vehicles, and we got information from them. And basically what we learned is that that industry works a lot differently than what the road weather industry uses, and typically rather than being a connection between the plow and a central office or like a road management system, they prefer to send their data to a cloud-based system, so they, a network operations center. And a lot of the data that is there is it is that basic data about the location, and also about what the load is carrying. So you can think of those are pretty parallel to the winter maintenance industry. But they aren't interested in a lot of other factors. They don't seem to have an interest in the environmental factors like the road weather industry. What they do want to capture is the ECM codes, the electronic control module code, so any information that's coming right off the vehicle. So I think that is an opportunity for the winter maintenance industry to potentially be able to piggyback off of. The winter maintenance industry has a lot of these systems that collect a lot of environmental sensors, but less that get into the electronic control modules, whereas the freight industry, basically they call it a kind of an opportunistic approach to it. If it's easy to get off the vehicle, then they get it, and if it's more difficult than that, they don't necessarily get it. I think I had covered this one on the previous slide, but basically looking for driver and load data, location data, and then anything that they can grab off the CAN bus. So the two off-the-shelf proprietary systems that we found to be most prominent are made by PeopleNet, and Qualcomm has an OmniTrack system. Then there was other systems out there that we weren't able to find out much about, more proprietary systems. So coming up with some conclusions about this is there's a real incentive for the winter, a public agency to encourage cooperation between vendors, whereas on the freight industry side, it's not as prominent. It's a pretty simple amount of information that they want to get from their vehicles, and they didn't see that need for a plug-and-play. And further than that, they thought that, I guess you could say, encapsulating the data types around a specific module, like this plug-and-play concept, they thought that would reduce the opportunity for innovation in the future. So I guess the basic conclusion is that I don't think there's much we can take from the freight industry other than potentially a good opportunity to piggyback on what they are using, but in addition to what the winter road maintenance industry is using, rather than supplementing or rather than replacing it. So then, after we completed those surveys, we had a project meeting with the whole subcommittee, and basically came to the conclusion that rather than coming up with a single plug-and-play, it needs to be more of a family of standards. And the next slide has those family of standards that we're recommending, and potentially it should be kept open. But basically, there's lots of different data types out there, and we need to be flexible and agile, being able to incorporate them in the future. So that's what this slide is about. It's rather than having a master protocol that sets the standard everywhere, the preference is to endorse, I guess you could say, some of these other protocols that have already made good strides with in each of their respective arenas. So I'll just quickly summarize the family of standards as it, what came out of that meeting as it stands today. First, the plug-and-play. So this was phase 1. That's the integration of the AVL system and spreader controller. NTCIP 1204. So the NTCIP standard is generally an IPS system standard. So, for example, controlling dynamic message signs or controlling cameras, all of that type of IPS work. But 1204 is specifically related to the road weather industry, and it may not have been put into place with the thought of a mobile application in mind, but it does include a lot of the environmental factors that we're interested in, as well as location. So I'm guessing when that location was put in as a parameter, it was probably thought to be like a fixed location, but in our application too, we can use that location as the vehicle travels down the road to also provide information about location of a plow, and combining that with time, we could understand information about speed of a plow. J2735 and J2945 are DSRC dedicated short-range communications protocol. So as you've heard about connected vehicles, and these are the specific protocols that will be used for those connected vehicle applications. And the road weather application is not necessarily the first one that will be passed and certified and used, but these protocols are expected to continue to be developed, and would include that. I remember seeing that application of an icy spot on the road, and vehicles detect the icy spot and then communicate it to other vehicles that are further upstream from that spot. Next, maintenance decision support system protocols. So the thought there is that these are, to some extent, standalone systems, and trying to encapsulate that MDSS data and could potentially limit its opportunity for future development. So the idea here is to endorse the MDSS protocols that are used today. And then the last bullet here is that future protocols that will meet the needs of the road weather community. The idea is to keep these future protocols in mind, and when a new protocol comes along, a new application comes along, rather than just say that, no, that's not a plug-and-play protocol, endorsed protocol, carefully assess it and work with the industry that's developing it so it meets the needs that we're identifying here. So finally, the conclusion and recommendations. Again, we had that meeting to talk about what this family actually looks like, or what the plug-and-play protocol actually looks like. And we identified 2 roles here. One is the FHWA role, and so specifically related to the automotive industry, and Gabe Guevara gave us input on this. FHWA is going to encourage them to go through the systems engineering process, and then establish requirements to make sure that road weather parameters are not overlooked. So we hear a lot about what that automotive industry is moving forward with, and the role here is to make sure that the road weather parameters are not overlooked. On the state procurement role, the idea is to encourage the industry to meet these standards and protocols that have been selected. When you develop your agency's boilerplate for procurement or put out their procurement contract, pick the protocols and standards that will transition to these plug-and-play endorsed standards. Okay, and then here's our contact information, and I just want to thank the team here, besides the entire subcommittee, but the subcommittee lead was Alan Williams from Virginia DOT, and the CLEAROS liaison was Greg Wadley from CLEAROS and CTC, and then I'm Scott Peterson from SRF as the PI. And I think now would be a good time to jump over to the chat, and I did see a couple questions come in, and now I can address those while we're finishing this presentation. Sorry, my chat pod is really small.
Thank you, Scott. I do want, this is Greg Wadley, I do want to jump in really quick and just say thanks, Scott, for that presentation. And one of the things I forgot to mention at the very beginning is that Scott will be taking the comments and some of the questions, any feedback that you have during this webinar, and include that in the draft final report that he's putting together that we should have by the end of the week. And that we'll also obviously be taking your comments and feedback on that draft final report and incorporating those into the revised final report. And if we need to bring the subcommittee together one more time in order to discuss those, we'll do that as well. But this is just another step in sort of bringing in, for presenting the information and bringing in some of the comments that we have. So with that, Scott Peterson, would you like me to go through and read the questions, or do you want to read them?
Well, yeah, why don't you read them? That'll be fine. Okay.
So the first question we have is from Scott Lucas of Ohio, and he asks, which states are weighing bed weight?
Okay, thanks, Scott. Yeah, I'd have to go look at our survey results, and maybe I can do that when we're off the call here. I don't recall it in particular.
Okay. From Justin Drossi in Michigan, how many states were surveyed?
Okay, yeah, right. So Justin asks, he wants to make sure there's a good sample size, and it was, I don't remember the specific number off the top of my head, but it was over 20 responses that we got, something like 25 responses. And I should also mention that we also got some, they were kind of hard to come by, but we also got a few international responses. I think three from Canada and one from Europe. So unfortunately that part of it wasn't so representative. I would say it's a small sample size, but we did actually get a good participation from the U.S.
Okay. Alan Williams of Virginia is asking, is there a level of need for the data which would be a break point between something that we should consider important versus lesser importance?
Right, yeah, and I think that's a really good consideration. So, and I think what Alan's referring to is when we were looking at those charts of each data parameter that is used and how important it is, and then the gap analysis. So the way I broke it down was something like 0 to 40% was like less important, and then 40 to 60 was medium important, and then 60 plus was very important. But I would say that was pretty arbitrary, and this is what we're going to put in the report is kind of those color codings. But I would say that anything that is borderline needs to be assessed. So I wouldn't want to draw that line very firmly, but if you're up in the, say, 80%, then okay, yes, definitely very important. If you're 60 to 80, then it's important, but you need to assess it for your agency. Some kind of thought should go into it like that. 40 to 60, that's getting to be where it's if it's a low-cost item to add, like for example, it comes free with the equipment you're buying, that's probably good to use, but it's maybe not worth extra effort to be able to add it. And then maybe lower than that, it would be if your agency has found a need for that kind of data in the past, you might look at it more closely.
Is there's no other questions or comments, I'm going to go ahead and thank everybody for your contribution today and for sitting in. Thank you, Scott, for your work on this. And like I say, the draft final report is coming. We'll have opportunities to comment on that. And thank you very much, everybody, and have a great week.